Alright guys, today we're going to talk about different types of graphs. And there are several different types of graphs that we're going to address, but the first type of graph that we're going to talk about is a frequency table. And a frequency table uses tally marks to record and display how frequently an event happened. And a nice example of a frequency table is given right down here. Now, if you'll notice from the instructions, it says that this frequency table is a survey of students' favorite sport. So what somebody did is they went out and they asked a whole bunch of students what their favorite sport was, and they recorded the results. So in the first column, you'll notice that the different sports that they received as an answer are displayed. So some students said basketball, some said football, soccer, and baseball. The second column is a tally column. So this is kind of like their scratch work here. Anytime someone said basketball was their favorite sport, they came and put a tally mark here. Now, the third column is a frequency column, and what the frequency column is about is they took the work from the tally column and made it easy to read. So what they did is they said, alright, I have 5, 10, 15 tally marks here. That means the frequency is 15 people said that basketball was their favorite sport. So they took this information and they made it easy to read, so you could quickly look at the frequency table and know what or the number of students that said that sport was their favorite. Now, the next type of graph that we're going to talk about is a bar graph. And a bar graph compares categories of data with bars representing the frequencies. So we're going to take this information from the frequency table and create a bar graph. Now, the most important part of any graph, it doesn't matter what kind it is always going to be the title. Now the title needs to describe what's happening in the graph or the frequency table so someone can look at it and automatically know what they're talking about. So 9 times out of 10 you can determine a great title for your graph just by the information that they give you in the problem. So for example, on number 1, make a bar graph to display the data from the survey of students' favorite sports. So we know that this frequency table was a survey of students' favorite sports. So we want to take that information and make a great title for this graph. So since we know we're talking about sports, we could call it sports, but that's not enough information to really get a good feel of what's going on. So I think if we just take the student's favorite sport and apply it, I think that would be a great title, because that means, alright, we're looking at a whole bunch of students' favorite sports here. So the important part of your title is that it needs to go on top of your graph and it needs to be capitalized. So let's go ahead and write student's favorite sport on top of the graph, and notice how the first letter of my words are capitalized. This graph is about student's favorite sport. Now, if at any time I'm going faster than you are, please feel free to pause the video and to get caught up. Now, we need to talk about the x-axis and the y-axis. We have 2 axes here, and they are going to describe the frequency table. Now, there are 2 important parts of the frequency table. If you'll remember, the tally and the frequency part were essentially the same thing. So the tally part's not really what we're looking at. We need to compare 2 things, the sport and the frequency. Now, since this is a bar graph, the sport, what we're talking about, what we're comparing, is going to go on the bottom axis here. So first, before we start labeling everything, we need to say what this axis is. So this axis is going to be talking about sports. So I'm going to leave some space under here so I can write what each one's going to be, but I'm going to label this axis sport. Notice again how it's capitalized. Again, I have space because I want to make sure that I have room to write what each sport I'm working with is. But now that I have the axis labeled, I can go back through and I can list each sport that I was talking about. So I have 4 sports here. Now, the next part that we're going to do is key to a bar graph. Now, a bar graph is comparing categories of data with bars. But what's important about those bar graphs, those bars from the bar graphs, is that there are spaces in between each one. So the bars are going to go in between these lines here, and I have 4 different sports, so I need to skip a line and start with basketball. Now, please do not write it like this. This is very hard to read, and it can get sloppy, and that's just not how people work. So what I would like you to do is take your paper and rotate it, and we're going to rotate it 90 degrees to the right, and we're going to write it left to right just like normal. So if you'll notice, I have a capitalized letter here. I've skipped the first column, and I've written it normally right next to each other, not top to bottom, right next to each other. Then the next sport is football. So again, we want to skip this section here because we want a space in between the bars, and the next one will be football. And then we skip again in soccer, and skip again in baseball. Again, if you need to pause the video to get those written down, please feel free to do so. The next axis that we are going to talk about is this axis right here. Now again, there were 2 important parts to this graph, what we were talking about and the frequency. That means this axis right here is going to be dealing with the frequency of the students that say it's their favorite sport. So a good title or a good label for this axis would be frequency. So with your paper still rotated, because again we don't write top to bottom, we write left to right, we can go ahead and call that axis the frequency axis. Now, we have everything labeled, but finally we need numbers here because the frequency is dealing with numbers, and we need to make sure that they are in a pattern. We can't just go through and write all the numbers in order of 15, 18, 21, 25. That doesn't give us a pattern. We need to come up with something called a scale, and a scale is a pattern of numbers that's going to make these fit on my axis. So if we count here, we're starting here at 0. We have 1, 2, 3, 4, 5, 6, 7 lines. I have 7 lines that I'm able to use, and the biggest number that I need to get to is 25. So if I counted by ones, I would start at 0, and I would have 1, 2, 3, and I would not get all the way to 25. So I can't count by ones. My next assumption would usually be to count by 2, so 0, 2, 4, 6, 8, 10, 12, 14, that's not quite enough. Next I could maybe try 3s, but that's not really a number that we count by often. So what if I count by 5? 0, 5, 10, 15, 20, 25, 30, 35. That does get me to 25 and past, which is okay. So I'm going to go ahead and label each line with a number and a scale of 5. Again, what I did is I took how many lines there were, and I figured out what I needed to count by to get to my highest number a little bit past it. Now I could also use a scale of maybe 10, but if I use 10 I would have 0, 10, 20, 30. That means all of my data would be squished down here and it would be kind of hard to see. So we don't want our scale too big because we want to make sure that it's still easy to read. So I think by 5s is a great scale to have on this graph. Now the next thing that we need to do is we need to start graphing each frequency for the sport. So this is when you're going to need your straight edge. Now, basketball, it said the frequency of students that chose basketball as their favorite sport was 15. So 15 students said, you know what, basketball is my favorite sport. So I'm going to come over here to basketball. This column represents the students who said basketball is their favorite sport. And I'm going to go up to 15, and do not freehand this. We want this as neat and nice as possible. And I'm going to find 15, and I'm going to use my straight edge to draw a line over that segment. Then I'm going to use my straight edge to connect it straight down on each side. So it should look something like that. Next, sometimes it's a little bit hard to see that, especially if you're using a pencil on these lines, and we don't want to like overdo it with how much we use for a pencil. we need to shade this bar in. Now, if you're using your pencil, you do not have to fill it in every little bit. You can just shade something like this just so you can see it. Or if you choose to, you can use a highlighter. And to use a highlighter, you just need to fill it in. You don't need to overdo it or spend a ton of time on it, just so we can see that it's a bar there. Now, the final part to this graph. We are not done with the information from basketball. Sometimes when you look at a graph, you can look at that and say, well, that looks like it's 15, but how do we know for sure? Because there might be some human error there. What if someone said, or 14 kids said basketball was their favorite sport, and we just have a little bit of error there? So to make absolutely sure that we know this is at 15, I want to take the frequency that we have and I want to write it right above there. That way we know without a doubt. Basketball, 15 students said it was their favorite sport. Okay, next we can go to football. Football has a frequency of 25. So in the column for football, I'm going to find 25. I'm going to use my straight edge to draw the segment where it should be, and then use my straight edge to connect down on both sides. Then we can use our pencil or our highlighter to shade in. Either or is fine with me. And finally, what we need to do is we need to write the frequency on top of it. Again, feel free to pause the video if I'm going too fast. Soccer is the next frequency. Now, soccer said 18 people said that was their favorite sport. So I get my straight edge and I want to find soccer here. Well, if you'll remember, our scale went by fives, and 5 is not a number that goes into 18 very nicely, so we have to estimate here. And this is where these numbers on top are really important, because I know that 18 is about halfway between 15 and 20, so I can come over here and I can say, well, 18 is about right there, and connect it down on both sides, shade it in with whatever I choose to use. And if someone were to look at this graph, they wouldn't know for sure what that is unless we told them, absolutely, we need to write our frequency on top. This is 18. 18 students said that soccer was their favorite sport. Now, go ahead and pause the video, do baseball on your own, and come back to check with what it looks like in a second. When you're done, this should be your final graph. Notice we used our straight edges, we shaded in the bars, there are spaces in between the bars, and then we have our frequency on top of our bars that we graphed. We also have nice labels, it's very easy to read. I have no doubt that if someone were to come look at this graph, they could tell me exactly, oh, they took a survey of students' favorite sports. 15 students said their basketball was a favorite sport, 18 said soccer. Easily be able to read the graph. Now the next kind of graph we're going to talk about is a histogram. And a histogram is very, very similar to a bar graph. However, instead of comparing types of things like sports or food, they're comparing numerical data. So for example, number 2 says, make a histogram for the birth weight of newborn babies. Now, we need to start just like we did with the bar graph. We still need to choose a good title to represent this data. And again, they were very clear on what we're talking about. We're talking about the birth weight of newborn babies. So I'm going to go ahead and have my title say birth weight of newborn babies. Capitalize the proper letters here. You guys know how to do that. You've been learning this for a while. Next, I'm going to look at what we're comparing. We're comparing the weight in pounds and the number of babies that were born at that weight. So for example, this is a range of 5 to 5.9 pounds. And they said there are 4 babies that when they were born weighed anywhere from 5 pounds to 5.9 pounds. Here, there were 11 babies that when they were born weighed 8 to 8.9 pounds. So we're going to make a graph talking or displaying this type of data. Now, this is different than the bar graph because the bar graph compared sports: basketball, football, soccer, baseball. Those four sports really are not related to one another. They're not connected to one another, so notice there's spaces in between them. Now, numbers are related to one another. 5.9 goes right on to 6. 6.9 goes right on to 7. Numbers are fluid. They connect to one another. So when we make our axis labels, they're going to be a little bit different. Now, number of babies is kind of like another way of saying frequency. This is the frequency of babies that were born at that weight. So just keep that in mind. This is kind of like a frequency table. They just labeled it a little bit differently. So first of all, let's start with this bottom axis here. The bottom axis is where I'm wanting to list all of the weights, the possible weights that we're talking about. So I'm going to go ahead and label that as weight. And notice how in parentheses I put how we're measuring the weight. That's really important. I want to make sure people understand that we're talking about weight in pounds, because if they go across the sea and they're in Europe, they might be talking in kilograms or grams, or they might be talking in, ounces. We are talking weight in pounds. So make sure you tell me what we're measuring this in. Now, just like we did with number 1, we want to take our paper and rotate it 90 degrees to the right, because we write from left to right, not top to bottom. And we are going to take all of our categories here, 5 to 5.9, 6 to 6.9, 7 to 7.9, and we're going to put them down on this axis like we did with number 1. But since this is a histogram, not a bar graph, there are no spaces in between these bars. So if you'll notice, I have 5 to 5.9 in the first one, and I go straight to the next one, 6 to 6.9, then 7 to 7.9, because one flows right into the next one. So bar graphs are comparing different things, and they are spaced in between the bars. Histograms are comparing numerical data, and they are next to each other. So since we have a weight on our bottom axis, now on our left axis, we're going to put the number of babies. Now, like I said, this is like a frequency table. So I like to use frequency instead of number of babies. If you choose to use number of babies, I probably won't be too picky about it, but this is the frequency. This is how frequently it's happening. Now, again, let's try and figure out a scale. So I have 1, 2, 3, 4, 5, 6, 7 lines that I can use, and the highest number that I need to get to is 14. So if I do a little bit of math there, 7 lines, and I need to get to 14, well, 14 divided by 7 is 2, which means I could easily use a scale factor of 2. Now, before I put the numbers down, I'm going to double check. If I start here at 0, and I count 2, 4, 6, 8, 10, 12, 14. I definitely can get all the way up to 14. So let's start with 5 to 5.9 pounds and get your straight edge out. It said there were 4 babies that were born and weighed between 5 and 5.9. Oh, excuse me. We got to put our scale first. And there's our scale. If you need to pause that, you're more than welcome to put down your scale. Now we can get our straight edge, and it said there are 4 babies that weighed between 5 and 5.9 pounds. So here is the 5 and 5.9 pound area. Go up to 4, use your straight edge, and we're going to connect it straight down just like we did with the bar graph. There's no difference here so far. Again, use your pencil or your highlighter to shade that in. And just like we did with the bar graph, we need to put what the actual number was on top of it. So there's no confusion as to what we are working with. The next weight was 6 to 6.9 pounds. And they said there are 12 babies that were 6 to 6.9 pounds when they were born. So I can come here, 6 to 6.9 pounds, go all the way up to 12, and we're going to use our straight edge to draw the top and then connect it straight down. Again, we'll shade it in. And we're going to write the number on top. We're going to go through and do this for every single one of these numbers. So go ahead and pause the video, and I would like you to finish the drawing of this histogram. Alright, when you're done, it should look something like this. Now notice, it does look a lot like a bar graph, but they are all pushed together. There's no spaces in between my bars. So bar graph has spaces, and we're comparing things. Histogram, there's no spaces. We're comparing numerical values. Okay, next we're going to talk about a line graph. Now a line graph usually shows how data changes over time. Now, a line graph is different than a bar graph as it clearly doesn't use bars, it uses a line. So on number 3 it says, Jessica recorded the temperature in her backyard, in degrees Fahrenheit, every hour for a 12-hour period starting at 8 a.m. The results are shown in this table below. Create a line graph to represent her findings. So if you'll see here, we've got a graph here, a table, and it says this table is showing the recorded temperatures for August 1st. At 8 a.m. it was 62 degrees, at 9 a.m. it was 66 degrees, and you can see as time goes on what's happening to the temperature. So we want to take this information and make a line graph out of it. So the first thing that we need to do is create a title, and what's awesome is they already have a title in this table for us, so I say we just take that title and transfer it directly over to the graph, and we can say that it is recorded temperatures for August 1st. Don't forget to capitalize the correct letters. Now, as you can see, we're comparing two things. There's a gray column and a white column, and I know that it's a little weird because it's split up, but that's okay. The gray column represents time. The white column represents the temperature at that time. So we're comparing time to temperature. Now, to determine which one goes on which axes, you need to look at what they are. Whenever we are comparing time to something, time is always going to be on this bottom axis, alright? So, we want to label this guy down here at time with a capital T. And then we want to bring what time we're working with over, just like we did with 1 and 2. We start at 8 and we go all the way to 7 p.m. But here's what's different about a line graph from a bar graph or a histogram. On a bar graph or a histogram, we were labeling the spaces in between the lines. With a line graph, we actually are wanting to label the lines themselves. So again, turn your paper 90 degrees to the right, and we write left to right, not up and down. And I'm going to start on this line right here, and I'm going to label this line 8 o'clock, and then 9 o'clock, 10 o'clock, 11 o'clock, and it's going to look something like this. Now if you'd like to put the AM and PM, that's fine. I probably should have, but I did not. Now if this bottom axis is time, that means this left axis has to deal with these dudes right here. Well, this is the temperature that we're working with. So we're going to label this axis over here temperature, but notice in parentheses we need to say how we are measuring temperature, which my pen won't work here, but we need to put in degrees Fahrenheit. Now we need to come up with a scale. So if I look here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines, and the highest degree, the highest temperature that I need to get to is 88. So 88 divided by 10 is a little bit more than 8, but that's a weird scale to count by. So logically, we could have a scale by tens. We could start at 0 degrees and go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. However, to me that's kind of a waste because the lowest temperature that we have is 62 degrees and the highest temperature we have is 88 degrees. That means all of my graph will really be smushed in this area here. And that's going to be really hard to decipher what's going on. That leaves a lot of wasted graph down here and some wasted graph up here. So instead of counting by tens and starting at 0, we're going to do something a little bit different. We're going to put this little squiggle down here at the bottom. And what that means is my graph is not starting at 0. If I put this little squiggle, that means there's more graph down here, but there's nothing down there, so I'm choosing to start up here. And what I'm actually going to do is start at 60 and count by 5s. So I have my squiggle here. I start at 60, 65, 70, 75, 80, 85, 90, 95, 100, 105. That spreads my graph out a little bit, and that makes it a little bit easier to read. Now, once we have our axes, we can go through and we can start to plot this data. So first of all, at 8 a.m., Jessica says it was 62 degrees in her backyard. So I'm going to come here to the line for 8 a.m. and I'm going to find where 62 is. Well, here's 60 and here's 65. And I know that 62 is about halfway between 60 and 65, so I'm going to put a dot there. Next, at 9 a.m., she said it was 66 degrees. So I'm going to come here for 9 a.m., find where 66 would be, put a dot, and right away when I do that, I'm going to get my straight edge and connect those two dots. And the reason that I do that is because by the end we're going to have so many dots on this graph that it's going to be difficult to see what connects to what. So as I'm going to connect these dots in order so I make sure I don't miss one. At 10 a.m., Jessica said it was 70 degrees. So here is 10 a.m., I'm going to go up to 70 degrees, put a dot. Then I can get my straight edge and connect it to the next one. 11 a.m. they said was 75 degrees. Plot the point, connect it with your straight edge, and go ahead and pause the video and continue to finish this graph. I want you to go all the way through 7 p.m. When you're done, it should look like this. And this is a great representation of a line graph because you can see that it's clearly rising in temperature, rising in temperature, rising in temperature, and it looks like it's at a constant rate. It looks like it's so many degrees every hour, but there's a little bit of change here and there. And then it hits its highest temperature at 5 p.m., and if we look at the table, we can confirm that. And then it starts to fall a little bit before she stops recording. So, when you are finished, a line graph gives you a great representation of how something is changing over time. Now, the next kind of graph that we're going to talk about is a stem and leaf plot. A stem and leaf plot is more of a way to organize data than it is a graph. Now, a stem and leaf plot takes your information and it helps you put it in numerical order, and it splits it in a different way to read it. It's a more organized way. So it says the digits of the least place value are usually forming the leaves, and the rest of the digits form the stems. So what we're going to do is we're actually going to take a number, and we are going to split it into a stem and a leaf. Now, for example, if I have the number 16, we know that this is the tens place, and this is the ones place. We would split that. The tens would be the stem, and the leaf would be the ones. So we would read this instead of 1, 6 as 1, 10 and 6 ones. We would read this as 16, but it helps to organize the data. So on number 4, It says the speeds in miles per hour of 20 of the fastest land animals are listed on the table below. Use the data to make a stem and leaf plot. Now, just like with the graph, we need to make sure that we give this a nice title. Now, the title is clearly given to us, the speeds in miles per hour of 20 of the fastest land animals. So, I'm going to go ahead and just put that up here. Speeds Wow. So I have my title here, Speed in Miles per Hour of the Fastest Land Animals. Now, notice I did label what they measured it in. That way it's easy for me to understand, okay, we're talking in miles per hour here, not kilometers per hour. So, now what we need to do is we need to use this data to make a stem and leaf plot. And the easiest way to do this is to start numerical order. So we want to look at this table, and we want to find the smallest number. So if we look here, the smallest number that we have is 32. So I'm going to take this 32, and I'm going to put the tens value in the stem, and the ones value in the leaf. And then this is really important, once you're done with it, cross it off, because we don't want to use it twice. Then we're just going to take this information and continue to put it in the stem and leaf plot in numerical order. So I'm going to find the next smallest number, which again is 32. But instead of writing 32 again, that's just going to make one really long list. That's going to make it very hard to read. We don't want to do that. Instead, we already have a tens value of 3. We just want to come here after the first leaf, and we want to add a second leaf. So this is also a 32. So how we read this is we have a 32 and we have a 32. So we have two 32s right here. Now we can find the next smallest number, which is 35. So we have a 30 already. Now we can add a 5, cross it off. The next smallest number, again, is a 35. Add a 5, cross it off. The next smallest number, we have yet another 35 right here. So add a 5, cross it off. The next smallest number is 36. Add a 6 and cross it off. So here I have my 30s. I have 32, 32, 35, 35, 35, and 36. It's just a nice way to organize your data so it doesn't take up a lot of room and it's easy to read. So let's find the next smallest number. The next smallest speed that they have listed is 40. So the tens value, which is our stem, is a 4, and the leaf value, which is our ones place, is a 0. Cross it off once you've listed it. Then the next smallest number, which is another 40. Put the 0, cross it off. And we can continue to list our data in this order. So I have 40, I have another 40 here, and another 40 here. Notice each time we cross it off so we don't have too many. And then the next smallest number would be 42. Then we have a 43. Then we have a 45. And another 45. And go ahead, we have 1, 2, 3, 4, 5 numbers left. Pause the video and add those 5 numbers to our stem and leaf plot, please. Once you're done, it should look like this guy here. And if you'll notice, we started with 1, 2, 3, 4 by 1, 2, 3, 4, 5. We had 20 numbers here, so it says 20 of the fastest land animals. Now, if I want to make sure that I have all the numbers, what I'm going to do is I'm actually going to count the leaves. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Oop, I forgot an 8 here. 20. So I have 20 of these speeds. I have 20 leaves. I have 20 of the fastest land animals. That means I have all of my numbers. Now again, how we read this: 32, 43, 50, 61. It's very important that we do not read it as 3 and 2, 3 and 2. That is one number. Now finally, there is one very, very important part of a stem and leaf plot that we need to have, and that is the key. Now the key tells us how to read it, because we don't really know if this is 32, or maybe the information is trying to tell us that this is 3.2. What is going to tell us that is the key. So in any corner, I don't care, I'm going to put it down here, we need to put a key. And we just need to take one number. So for me, I'm going to take the first number that I used because it's easiest. And I'm going to show that 3 bar 2 equals 32. That means I can come down here and look at it and say, okay, I've got a stem over here and a leaf over here. 3 bar 2 is actually 32. And that's going to help whoever reads your stem and leaf plot decipher how fast these animals are actually going. Now the final type of graph we're going to talk about is a circle graph. A circle graph is a graph that shows the relationships between the parts of the data and the whole. Now the circle represents all of the data. So on number 5, it says the table shows how Lily spent 8 hours of one day at summer camp. We need to make a circle graph of the data. Now I was really nice to you guys, and I actually already made the circle graph. We're just going to figure out the information that goes with it. So a circle graph is also sometimes known as a pie chart, just so we're aware. Now, Lily's day at camp, she had 8 hours in one day. So it says she spent 3 hours canoeing, 1 hour making crafts, 2 hours eating, and 2 hours hiking. Now just to be sure, I want to make sure that really adds up to 8 hours. So let's add these together. 3 plus 1 is 4, plus 2 is 6, plus 2 is 8. So there are a total of 8 hours that are accounted for here. Now the first column that we need to fill out is something called the ratio. And the ratio is going to help us split her hours into a fraction or a decimal. So what we need to do for the ratio, for example, for canoeing, we need to take the number of hours she spent canoeing, which we said was 3, and divide it by the total number of hours that she had in her day. So the ratio is going to be 3 over 8, because they said she had 8 total hours in the day. Now what I would like you to do is get out your calculator. If you don't have it out yet, go ahead and pause the video and get it out. And we're going to find what 3 over 8 is as a decimal. So in our calculator, we can put 3 divided by 8, and we get a terminating decimal, which is good, of 0.375. So next to 3/8, I want us to put equals 0.375. Okay? Now we're going to go down the line here and we're going to do the same thing for crafts, eating, and hiking. So the ratio starts as a fraction. I want the number of hours she spent, so 1 hour for crafts, out of the total number of hours in the day, which was 8. And then we're going to put that into our calculator. So 1 divided by 8 is a terminating decimal of 0.125. And then go ahead and do that for eating and hiking. Now, hopefully for eating you got 2 over 8 for the ratio, which I understand can be simplified to 1/4, and if you did that, that's fine. But as a decimal, which is what we really want, we get 0.25, and hiking should be the same thing. Now the next column, the last column, is degrees. And this is going to help us determine how many degrees of the circle are we going to allot for each activity. Now, before we start this, first of all, we need to refresh our memory on how many degrees are in a circle total. Now, there are always 360 degrees in a circle. Now, to figure out how many degrees goes to each activity, we are going to take that ratio, that decimal, and multiply it by how many total degrees are in the circle. So here's what I want us to do. We're going to show this work over here on the right-hand side, just so when you get to your homework and you look at it and you say, wait, what did I do here again? We are going to be able to look back and see, oh, that's right, I multiplied it. So here I need to take my ratio of 0.375 375 and multiply it by 360 degrees. So once you've written it there, we can put it into our calculator. 0.375 times 360. And that gives us 135. That means 135 degrees of this circle is going to be, and we need our label there, come on, is going to be canoeing. Now we can go to crafts. So over here on the right, 0.125, that was my ratio, times 360. And let's get out our calculators. 0.125 times 360. And that should be 45 degrees. So 45 degrees is for crafts. Go ahead and pause the video and determine the number of degrees for eating and hiking on your own. So 90 degrees should go for eating, and 90 degrees should go for hiking. And again, that should make sense. Since there were the same number of hours eating as there were hiking, it should be the same ratio and the same degrees. Now we can come over here to our circle graph. As you'll notice, I've already split up this information. Now we just need to make sure it makes sense. So we know that eating and hiking should be the same size, and it looks like they are. And canoeing has the most degrees. It has 135 degrees here, so it should be the biggest slice, and crafts should be the smallest slice. Now here, I have these boxes that we need to put information into, and those boxes need to have the percentage of her day put into it. So what we need to do is take the ratios that we have, these decimals, and turn them into percentages. Now it's been a little while since you guys have done this, so let's start with canoeing. Canoeing was 0.375 of her day. I need to take that ratio or that decimal and turn it into a percentage. And to do that, all we really need to do is multiply it by 100. Now, if you'll remember, yes, that's mathematical, but there was a shortcut to do that. We really just need to take this decimal here and move it 2 places to the right. So 0.375 is actually 37.5%. So we need to take this dude here and put it into the box for canoeing. That's going to say she spent 37.5% of her day canoeing. So we can come here and say 37.5, and don't forget your label. That's very important, percent. Next, we need to do the same thing for crafts. So the ratio for crafts was 0.125. So take that decimal place, move it 2 to the right, and crafts was 12.5%. Go ahead and pause the video and find the percentages for hiking and eating on your own. Hopefully you get that they were both 25% of the day. So again, this is a visual representation of what she did with her day, and it should make sense to you. You should see that, okay, this section is larger than these sections, it should be bigger. This is smaller, it should be smaller. That wraps up our practice on graphs. If you have any questions, please come and ask.